Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco's DevNet, and I want to talk to you today about how you can program your own DNA with APIC-EM APIs. And by DNA, I of course mean Cisco's digital network architecture. This is a lesson involved in our network programmability basics presentation, and we are in the module where we will talk about and cover network controllers and some of the different capabilities you can use network controllers as part of your network programmability strategy. We're in our first lesson here on DNA with APIC-EM, but we'll also talk about ACI programmability options, how you work with Cisco Meraki for the cloud, and we'll dive deeper into both DNA and ACI as well in later lessons. Now, if you want to follow along with me, I encourage it. Be sure to jump up to github.com/cisco-devnet/netprog_basics to download all of the code samples and README information for these lessons and labs. Every lab, including this one, has a README that details all the prerequisites and how you can set your laptop and environment up to follow along with me. And if you don't have access to the specific infrastructure that we're talking about, DevNet Sandbox has you ready to go. The README includes all of the information about which sandbox you want to take advantage of for these labs and exercises. Now, what we're going to talk about today in this lesson is general network, the APIC-EM controller architecture and the applications that are supported inside of APIC-EM that you as a network developer may be interested in taking advantage of. We'll talk specifically about how APIC-EM uses Swagger as an API framework to give us documentation and access to it. We'll look at how to use APIC-EM APIs along with Postman to test and validate those calls. And we will end by showing how we can actually build Python scripts to link together APIC-EM API calls to provide information and gain access out of the APIC-EM applications that are there. So network controller application architecture and applications. Now, if we think back to the SDN concept in software-defined networking, network controllers are a core element of software-defined networking. And the ideal is that the controller provides an application platform for developers to build apps on top of. Now, as a network developer or an application developer, you want to build an application and not have to worry about the underlying infrastructure that's actually providing all the capabilities. Which switches, how many switches, where the routers and firewalls are. An SDN controller should abstract all of that and then provide a consistent API that you can build your applications on top of. And that's exactly what APIC-EM is all about. Inside of the architecture for APIC-EM, what we'll find is that APIC-EM exposes those northbound REST APIs while it controls specifically all of the underlying services necessary to connect down to the infrastructure under the hood. It'll manage inventory for you. APIC-EM will handle all the role-based access control down into the network devices, deal with policy analysis, as well as programming the individual devices with the configuration deduced. And then there are the APIC-EM applications, which are what you as a developer are actually interested in working with. These provide capabilities for plug and play with zero-touch provisioning, information about the network topology and inventory, or maybe the path that traffic is taking across the network and the healthiness of that path. So as we talk about the REST APIs and we're working about programming with APIC-EM, those are the applications, those are the key areas that we're after. Now, though we're going to be focused on APIC-EM APIs and using those as a developer, let's start out by looking at the graphical user interface, because this will probably be your entry point into APIC-EM. When you log in, over on the left-hand side, you'll see a navigation pane that details all of the APIC-EM applications that are available, as well as some of the core functions such as discovery and inventory information. When you've selected a particular element of application in the navigation, the main work pane will give you access to the details, whether those are dashboard widgets like we see here, or actual configuration and input information that you can enter. Now, we are interested in the APIs, and right from the graphical interface, we've got a link that'll take you directly into the REST API documentation that we'll look at more in just a moment. And then finally, as you're working with APIC-EM, our developers building APIC-EM are interested in your thoughts and what you have to say. Down at the bottom, you'll find a link where you can submit suggestions directly to our developers on how we can improve APIC-EM for your use cases. Now, because what you're interested in is the applications that APIC-EM provides, let's talk about the 5 applications that are most commonly used today. Network inventory gives you the ability to both discover the network and the hosts that are available inside of the network. So using the APIs tied into network inventory, you can find out about all the details about the devices, the network switches, the routers, version control information, all of those details about the inventory. But not just the network infrastructure. Also the hosts that are connected to the network are available through the network inventory application. If you're interested in how that inventory is connected together, the topology application will build and manage dynamic network topologies inside of the GUI, or you can do that yourself using the API calls. Wanting to understand how traffic will actually flow across your network in real time when considering all of the elements that would go into policy, the path trace application will let you track those network flows and identify problem areas that may be causing issues. Day zero provisioning of your network infrastructure is done through network plug and play to make it very simple to take your infrastructure out of the box, plug it into the network, and let it automatically download the proper image and configuration to get started. And then finally, Easy QoS or Easy QoS gives the developer the ability to articulate what is the QoS policy you want implied in your network without having to pay attention and focus on the specific details and differences between infrastructure platforms, such as how many hardware queues are supported or which types of QoS are specifically supported. Articulate your policy in Easy QoS, and APIC-EM will translate that into the best configuration for the devices across your network. Now that we've seen those, let's talk about the APIs. And as far as APIC-EM goes, when we talk about APIs, APIC-EM has got swagger. Now, what I mean by swagger in this case is the Swagger Open API specification. What Swagger provides is tool sets for application developers providing APIs for their services to make sure that they design, document, and test their APIs in a format that will be well received by the consumers of those APIs. My favorite feature of Swagger is that it provides live documentation with integrated testing. So I always know that the API docs that I'm looking at are accurate because they're generated specifically by Swagger for us. And I have the ability to test my API calls to make sure that the API I'm looking at will give me the information or enable me to do what I'm after. We dive specifically into the Swagger view for APIC-EM. What we'll find is that the APIs are organized by category, which correspond roughly to individual applications. And then each API category will provide a relevant resource that's out there. Let's look at how that might look as we go through here. Once you're looking inside of the Swagger view, by selecting a specific resource inside there, in this case a network device resource out of the inventory area, we'll see the available API calls and methods. So I've selected network device, which comes out of the network device APIs, and now I can see that I've got a whole series of different APIs that are available, ranging from GET request to retrieve information, to put requests to send updates. I can even do delete requests to make changes to specific IDs inside of the APIC-EM through the interface that's there. Now, once you select a specific API call, we'll get the ability to actually read all of the documentation that's there. So in this case, we've selected the API call for get the network device by IP address information. We can see all the documentation is provided here inside of the API call. Oops, that's a really bad drawing. It's provided here underneath the API call inside of Swagger. Once I've reviewed all of that documentation, it gives me the ability to try it out directly. Simply by clicking on this button, it will send an API request off to the APIC-EM to give us the information. After clicking try it out, we'll be presented with the actual response that's there and all of the details we would be interested in as a developer trying to understand these APIs. We want to start out by looking at the response code. In this case, we got a 200 back, which would indicate a successful API call. The body of the response is provided as well, so we can see the information that comes back. In this case, we can see the details on that network device that corresponded to the IP that we looked at. And then lastly, all of the response headers are included down here as well so that you can look at what to expect to come back. Things that we may be interested in is the content type that was returned. In this case, APIC-EM is returning us application JSON content type as we go through. Now, as we think about the resources that are available through the APIs inside of APIC-EM, we're going to find that there are relationships between those. And so when we're talking about network devices have interfaces. So an interface as an API call you can make a reference to, but it will be linked back to a specific network device based on unique ID information. And then if you're looking at the hosts that are available inside of APIC-EM, a host will exist underneath and connected to a particular interface. So as you're working with and building applications leveraging the APIC-EM pieces, keep in mind the relationships that all of the resources that are supported have to each other that are out there. Now that we've understood and taken a look at the API documentation and how to read it using Swagger, let's put them to use using Postman. Now, as a reminder, Postman is that simple but powerful REST API client available as a standalone application or as a plugin to Google Chrome. Postman lets us save all of our APIs into collections, manage our environments for different types of APIC-EMs we may want to connect to, and even auto-generate code to jumpstart our actual programmability journey with Python. We'll see how those can be used all with APIC-EM here. To start out, we need to set up our environment inside of Postman for APIC-EM. Here we can see where I'm identifying the particular APIC-EM IP address, or in this case, host name that we're connecting to. We've got the username, the password, and then the port that APIC-EM is running on in this instance for this environment. With those variables defined inside of the environment, I can take advantage of them in URIs as well as bodies of content, as we'll see here when we log into the device. Now, our first step of interfacing with the APIC-EM is to do a login request. From an authentication perspective, APIC-EM uses a ticket or token method of authentication. So in order to make requests for network devices, host information, path information, you need to have a valid ticket to include inside of that request. You retrieve your ticket by making your initial API request will be to log into the device and retrieve your ticket. To do that, we'll build a post request inside of APIC-EM here, where we go ahead and provide inside of the body of the post our username and password. When we send that post request, we'll retrieve back in the body of our content the service ticket that's available, and now we have what we need to make actual API calls. Now, we don't want to have to necessarily copy and paste that service ticket that will change and expire over time into every follow-up API call. So let's take advantage of another feature of Postman, the ability to build tests and do dynamic variables that are in there. So as we can see here, what we're using is that test capability to write that common JSON, to review that response body, and then create a new environment variable called token that will then store the value that was returned by our login request. And we can see how we've built that here. With our token saved, now we can move ahead to actually retrieve information about the APIC-EM that's out there. Here we're building an API call to retrieve information about the network device. Let's see how these bits and pieces go together. Now, to retrieve information, obviously we want to process a GET request, and we can see that here inside of our Postman environment where we're sending our GET request. The URI that we're going to, or the resource that we're going to request is listed here, /API/v1/network device. And so we insert that as our API call inside of the Postman interface. And notice how we're using the variable APIC to represent the actual host that we're connected to. Now, what's interesting here is we build it, we do need to provide a special header to authenticate off to APIC-EM for us. And that header is called XAuth token with dashes in there. Now, we don't want to copy and paste the actual service ticket every time we go through, and so we're using that environment variable that we dynamically created using the tests following the login post request on the previous step. Now, with those in place, we also have the ability to set content type in an exception, or the content type that we may send, and then the content type we're interested in getting back. Now, in this case, I'm explicitly setting those. However, APIC-EM will default to application JSON if you don't send anything. However, I always recommend to be explicit with what you're interested in retrieving back. Once we've got our API call configured, we can go ahead and send it, and we'll be able to review our response that comes back through here in the body. Notice that we get our 200 OK back, and we get our response back. Indeed, it is in JSON here that we can then manipulate and work with. Now, APIC-EM using Postman is a great way to test out the APIs and become familiar with them. But at the end of the day, what you're actually trying to accomplish is probably more than make a single API call, in which case we will move to a programming language such as Python. Now, with Python, the reason we go to that area is because we want to be able to link these things together. Now, to get started, we can use the code generation capabilities of Postman to give us a starting point. Now, it is just a starting point, because let's keep a couple of factors in mind. Postman will give us our API calls, and it's going to hard code all of the host address header information, including the token that was necessary to make the API call that was there. We don't want to have those hard coded in our Python script any more than we wanted them hard coded into our collection. So we need to update and build a slightly more intricate Python script that can do all of that for us. Now, what I've done is I've started with all of the Python code that was auto-generated by Postman, and I've created this example that will dive into how we can actually string together the outputted code from Postman to construct a Python script that gives us everything that we need with a simple Python script that's out there. Let's dive in and look at all of the key components of this Python script and all of the code that goes into it. So the first bit we want to look at is, just like we had to do with Postman, we have to log into the APIC controller. And so what I've constructed here is a function called APIC login. The APIC login requires 3 parameters. It requires the host, the username, and the password of the APIC controller that we're going to log into. So those parameters are defined there. Now, using what we learned from Swagger and then verified inside of Postman, I know the URL format that we want to go ahead and create. So we're going to have HTTPS. We'll have the host address gets inserted using the format function. And then we're going to send that request off to API v1 ticket. Now, in order to log in successfully, we have to send a proper payload, and that payload includes the username and password for our APIC-EM controller. Now, a login request is a post request. And so here I'm using the exact code that Postman provided me to use the request library to send that post request to the specific URL, including the data from our payload that provides the username and password. Now, inside of the example script, I've saved the headers for content type and accept so that we can send those along. And then we'll set verify equals false to be safe here on the self-signed certificate. If your controller, your APIC-EM controller, has an actual signed certificate that you can trust, you could certainly use that. You could omit the verify equals false. Now, once we've made that request off to the APIC-EM controller, our function will return the body of the response, where we can actually retrieve the service ticket that will be necessary to make our following call. The next function that is created inside of this example is a function called network device list. The network device list will return, as you would expect, a list of network devices. And this function requires 2 parameters. It needs to know the host, what APIC-EM do we want to connect to, and it needs to know the ticket to use to make the API call out there successfully. Once we have those, we can then build our URL. Now, once again, the URL, we learned what it was using the Swagger documentation, and we verified it using Postman. And so now I can go ahead and construct that URL here. Now, we are adding an additional header. We need that header for the XAuth token, and we're going to make the value of that the ticket that was passed into this function. We'll send our response using the request library, and this is a GET request at this point. And we include all of the detail necessary, and then we'll return back to our script the contents of the response that are there. We've written 2 functions, right? One to log into the device, one to retrieve the network device list. And then here in this part of the code, we actually write what we want our script to accomplish. So we start out by logging into our APIC-EM. We'll then go ahead and get the device list by leveraging the network device list function that we created. And we can see where we're grabbing the APIC-EM host, which is the host name for our APIC-EM controller that was stored in our dictionary in our Python script. And then we're passing in the value of the service ticket that was retrieved by the login request. Now, that provides us back the list of all of the devices that are available in APIC-EM. So we'll use a basic Python loop to loop over each device in the devices list and then print out some basic information. We'll print out the management IP, platform type, and software version, and then identify which device we're in based on the device host name, and then indicate what family it's a member of. Let's take a look at what this script looks like in action. So here we can see where I'm executing Python space example1.py, which is that script we just took apart and took a look at all the components. Without providing any other input at this point, it goes ahead and successfully connects and logs in and authenticates to APIC-EM, retrieves the network device list, and then prints out the information as we explicitly set into our script. We can see the host names, the families, and then the management IP, platform type, and software versions for each of these devices. Now, in summary, we've taken a good starting look at APIC-EM, and what we did is we understand the APIC-EM architecture and applications, because it's the applications on APIC-EM that we're most likely to be interfacing with using our programmability skills. We saw how the Swagger API documentation baked directly into APIC-EM makes it super easy to explore all the APIs that are available, test them out, and understand everything that's expected to use them. We looked at how we can then move off from Swagger to Postman to send the API calls to APIC-EM and verify that they're working successfully as expected. And then we ended by creating an entire Python script that uses the APIC-EM APIs to log in as well as retrieve and print out the network device list that's there. Now, as we finish up this video, I want to make sure that you continue the Network Programmability Basics course. Now, we're going to move from the APIC-EM introduction here into ACI and Meraki controllers next. But inside of this module, inside of the Network Programmability Basics course, we also have deeper dives into different APIs for applications and how you can use those APIs to assist you with troubleshooting. So make sure to follow those videos as well. Now, if you didn't follow along inside of the examples and the demos that we ran here in the video, be sure to do them now. And also, of course, join me on DevNet at developer.cisco.com. You can access learning labs that cover APIC-EM as well as many more. And then we have several development sandboxes that you can test out the API calls against APIC-EM, leveraging either a virtualized or real-life physical infrastructure hanging off of an APIC-EM controller. If you have any more questions about the topics in this video or anything else, be sure to come find me. You can reach me via email or Spark at hapresto@cisco.com. I'm available on Twitter at hfpreston. And be sure to follow Cisco DevNet on all the social medias at Cisco DevNet. Also, if you want to follow us on GitHub, you'll occasionally find lots of good information on different examples of code covering network programmability and other architecture examples that are there. Thanks so much for joining me for this video today. I hope you found it worthwhile, and I look forward to seeing you in our next one. Thanks.